The wind whispers secrets. It carries with it the stories of the land it traverses, the history etched in every grain of dust it lifts. On Mars, these whispers are faint, almost imperceptible. But they are there, waiting to be heard. On Earth we feel its caress, hear its roar. The wind is a constant companion, a force that shapes our daily lives. It brings the scent of rain, the chill of winter, and the warmth of summer. It is a dynamic presence, ever-changing and ever-present. It shapes our world, carving mountains and painting deserts. Over millennia, the wind has sculpted the landscape, creating natural wonders and altering the course of rivers. It is a powerful artist, its brushstrokes visible in the shifting sands and eroded cliffs. On Mars, a planet shrouded in mystery, the wind whispers too. Though it is a different world, the wind there carries the same potential to reveal secrets. It moves across the barren surface, stirring the dust and hinting at the planet's hidden past. But its voice is faint, a murmur across millions of miles of space. The Martian wind is a subtle force, its presence felt more than heard. It is a ghostly whisper, a reminder of the planet's distant and enigmatic history. We listen intently, for in its whispers lie clues to the red planet's past and perhaps its future. Every gust of wind, every dust devil, holds a piece of the puzzle. By studying these patterns, scientists hope to unlock the secrets of Mars's climate and geological history. Understanding Martian wind is not just about satisfying scientific curiosity, it is about piecing together the story of a world that once may have harbored life. The wind's patterns can tell us about the planet's atmosphere, its weather systems, and how they have changed over time. It is about unraveling the story of a planet once so similar to our own, now a desolate, frigid world. Mars, with its dry riverbeds and ancient lake beds, hints at a time when it was warm and wet, a stark contrast to its current state. The wind is a key to understanding this transformation. By studying its wind, we learn about its ancient climate, its potential for life, and the challenges and opportunities that await us if we ever set foot on its dusty surface. The wind can reveal the presence of water vapor, the composition of the atmosphere, and the potential for sustaining human life. The wind on Mars is a storyteller, and we are eager listeners, ready to decipher its tales of a world lost and perhaps a future yet to be written. As we prepare for future missions, understanding the wind's behavior will be crucial for landing safely, building habitats, and exploring the Martian surface. The whispers of the wind are not just echoes of the past, but guides for our journey into the unknown. To capture the whisper of Martian wind, we have sent robotic emissaries equipped with ingenious tools. These instruments, designed to withstand the harsh Martian environment, act as our eyes and ears on the red planet, relaying valuable data back to Earth. One such instrument is the Rover Environmental Monitoring Station, or REMS, currently deployed on the Curiosity rover. REMS acts like a sophisticated weather station, measuring wind speed and direction, air pressure, temperature, and humidity. It utilizes sensitive sensors like tiny wind vanes to detect even the slightest movements in the Martian atmosphere. Another crucial instrument is the Mars Environmental Dynamics Analyzer, or MEDA, stationed on the Perseverance rover. MEDA is a suite of sensors that provide a comprehensive understanding of the Martian atmosphere and dust activity. It measures wind speed and direction, air pressure, temperature, and radiation, helping scientists paint a detailed picture of the Martian climate. Measuring wind on Mars is not a walk in the park. The red planet presents unique challenges that make data collection a complex and demanding task. One of the biggest hurdles is the thin Martian atmosphere, about 100 times thinner than Earth's. This means that even strong winds on Mars exert far less force than a gentle breeze on our planet, making their detection incredibly difficult. Another challenge arises from the Martian dust. Fine, powdery dust particles, ever present in the Martian air, can interfere with wind measurements. They can clog instruments, affect sensor readings, and create confusing patterns in the data. Imagine trying to measure wind speed with a fan constantly blowing dust in your face. Furthermore, the extreme temperatures and pressure variations on Mars can wreak havoc on sensitive instruments. Designing and operating equipment that can withstand these harsh conditions and still deliver accurate data requires remarkable engineering ingenuity. Section 4. Outsmarting the Red Planet, Overcoming Measurement Obstacles. Despite the formidable challenges, scientists and engineers have devised ingenious ways to overcome the obstacles and accurately measure wind on Mars. The Martian environment is harsh and unpredictable, with extreme temperatures, dust storms, and a thin atmosphere that makes traditional measurement techniques ineffective. However, the relentless pursuit of knowledge has driven these experts to innovate and adapt. They have developed highly sensitive instruments capable of detecting even the faintest whispers of the Martian wind. These instruments are not only advanced but also incredibly resilient, designed to withstand the rigors of space travel and the harsh conditions on Mars. The process of creating these instruments involves meticulous planning, cutting-edge technology, and a deep understanding of both engineering and planetary science. These instruments are rigorously tested and calibrated to ensure they provide reliable data in the face of extreme conditions. Testing often involves simulating the Martian environment in laboratories on Earth, where scientists can replicate the low temperatures, low pressure, and high levels of dust found on Mars. This ensures that the instruments will perform accurately once they are deployed on the Martian surface. To combat the issue of dust interference, scientists employ various strategies. Dust storms on Mars can be massive, covering the entire planet and lasting for weeks or even months. This dust can clog instruments and obscure measurements, making it a significant challenge for accurate data collection. For instance, some instruments use lasers to measure wind speed by tracking the movement of dust particles in the air. This technique, known as LiDAR, light detection and ranging, involves sending out laser pulses and measuring the time it takes for the light to bounce back after hitting dust particles. By analyzing these reflections, scientists can determine wind speed and direction with remarkable precision. Others utilize acoustic sensors to detect the subtle pressure changes caused by wind, filtering out the noise created by dust particles. These sensors can pick up minute variations in air pressure, which are then analyzed to infer wind patterns. This method is particularly useful in areas where dust levels are too high for optical instruments to function effectively. Moreover, scientists have become adept at interpreting data affected by dust and other environmental factors. The raw data collected by the instruments often contains a lot of noise, unwanted information that can obscure the true measurements. By understanding the characteristics of this noise, scientists can develop techniques to filter it out and reveal the underlying data. They use sophisticated computer models and algorithms to filter out noise, correct for errors, and extract accurate wind measurements from the raw data transmitted by the instruments on Mars. These models take into account various factors such as temperature fluctuations, atmospheric pressure changes, and dust density, allowing for a more accurate interpretation of the data. This combination of advanced technology and innovative problem-solving is what enables scientists to overcome the formidable measurement obstacles presented by the Red Planet. Section 5, A Tale of Two Winds, comparing Earth and Mars. While both Earth and Mars experience wind, their winds tell very different stories. The winds on these two planets are shaped by their unique atmospheres, climates, and geographical features, leading to fascinating differences and similarities that scientists are eager to explore. Earth's wind, driven by the uneven heating of the planet's surface and the Coriolis effect, plays a crucial role in regulating our climate, distributing heat and moisture across the globe. The Coriolis effect, caused by Earth's rotation, influences wind direction and creates distinct weather patterns, such as trade winds, westerlies, and polar easterlies. From gentle breezes that rustle the leaves in a forest to the raging hurricanes that can cause widespread destruction, Earth's wind is a powerful force shaping our world. It sculpts landscapes, drives ocean currents, and even affects human activities from agriculture to aviation. Martian wind, on the other hand, is a more subtle but equally fascinating phenomenon. Despite the thin atmosphere, which is only about 1% as dense as Earth's, Martian winds can reach impressive speeds, driven by the planet's unique environmental conditions. With its thin atmosphere and lack of liquid water, Mars experiences wind patterns distinct from those on Earth. The Martian atmosphere is composed mostly of carbon dioxide, with traces of nitrogen and argon, and this composition, combined with the planet's lower gravity, results in different wind behaviors. Martian winds are primarily driven by the temperature differences between day and night, as well as between the poles and the equator. During the day, the surface can heat up significantly, causing air to rise and create wind patterns. At night, the temperature drops rapidly, leading to different wind dynamics. One striking difference is the scale of dust storms. Martian dust storms can be truly colossal, sometimes covering the entire planet and lasting for months. These storms are driven by the intense temperature fluctuations and the fine dust particles that make up much of the Martian surface. While Earth experiences dust storms, they are dwarfed by the massive dust storms that can engulf the entire planet of Mars. On Earth, dust storms are typically localized and short-lived, but on Mars, they can become global events, significantly impacting the planet's climate and surface conditions. These global dust storms, lasting for months, are a testament to the power of Martian wind and its ability to reshape the planet's surface. The dust lifted by these storms can reach high altitudes, affecting the planet's temperature and even its appearance from space. Scientists continue to study these phenomena to understand their implications for future exploration and potential human habitation on Mars.